there are millions of domestic fans installed in the UK, into homes across the UK every year. In fact, since the implementation of the building regs, Part F, over the last couple of decades, there have been probably tens of millions of fans installed. So we've got millions of fans installed in walls all over Great Britain, and yet we've got over 5 million properties in the UK still suffering from condensation and mould. And we often get calls from property developers and building control officers asking us why some fans can meet building regs once installed and some can't. So the aim of today's demonstration is just really to prove why some fans work and some don't once installed. What I'm going to use is this test rig. It's basically a clear tube, and we put a lightweight disc down the tube like that, and when you put air down the tube the disc just lifts up, no problem. So just to demonstrate, I've got a 4-inch fan switched on here, and the fan's doing its job great. So this is a 4-inch intermittent fan, system 1, and if it's doing its job properly, then it's going to push air down the tube and meet building regs, no problem whatsoever. So what I've got 5 different fans, system 1 and system 3 fans, and I'm going to demonstrate using a recently calibrated anemometer and this test rig why some fans work and some don't. So there's a few fans here that I've just bought off the internet, so various system 1 type fans, so they're intermittent, and they've been designed to meet Part F of the building regs. So the minimum extract rate for a bathroom is 15 litres per second. So let's just see what these are doing. I'll just plug these in, switch them all on. So you can hear they're all on now, whirring away. So I'll get my anemometer and we'll test each one to see what each one's doing in free air first. So we'll start with this one. So like I say, I got this off the internet. It's fairly cheap fan, and on the box it says it meets Part F, so is it? So in free air, there you go, it's doing 21 litres per second. So, you know, if you're a contractor buying that, you'd obviously expect it to be meeting Part F, because it's in free air it's doing over 15, which is what it's expected. And here's another fan, similar fan. This is what you call an own brand fan. What's it doing? So 23 litres per second, so really exceeding building regs there. I've got another fan. (17, 19, 20 litres per second, so no problem. And you got the EnviroVent fan. That's doing 22 litres per second. Right, so in free air there's nothing between these fans, and like I say, if you're a contractor and you go into your local wholesalers or you go online and you see these in the box, they'll all say they meet Part F of the building regs because they're all exceeding 15 litres per second. So what is a fan? Basically all it is really, it's a piece of plastic with a motor and impeller, and it all depends on the quality of the motor and the impeller on whether you're going to get good performance. A lot of fans, unfortunately, they have these sleeve bearings which are really cheap to manufacture. You can buy them in the Far East for pence, but the problem is they don't last very long. They can't handle much resistance. They're powered by a very cheap motor, and they're turning a very cheap impeller. So you're relying on protecting your property and the health of the occupants using a cheap sleeve bearing and a very cheap impeller in the majority of cases. And that's the difference between the performance of a good fan and a bad fan. If you fit a good motor and a good impeller, you're going to get good performance. If you go for cheap, you're going to get poor performance. So what about on the test rig? Well, this centre tube has got a fixed grill on the top, so it's basically replicating a typical installation. So this fan was doing around about 20 litres per second, and if I just put it on the test rig, let's see what it's doing now. There you go, it's doing 21 litres per second. Alright, so with a wall liner, a 90-degree bend and a fixed grill, we're still far exceeding the building regs. And again, if I just put that on the tube, pushes the disc up no problem. So what about these other fans? So if I just put it on the tube first, you can see that it can't even move the disc. So it hasn't got the power to overcome the pressure, the small amount of pressure created by a wall liner and a grill. So if I put that on a typical installation, and we'll get the anemometer on it, and we'll see what it was doing. It was doing over 20 litres per second in free air. It's now dropped to 10. 11 litres per second, which means it's not meeting building regs. These are intermittent fans as well, so they spend 23 hours a day switched off. So when you switch it on, it's got to do its job. It needs to ventilate, otherwise you're going to get condensation and mould. Here's another one. So this was doing around about 21 litres. Installed 10 litres per second. Let's take that off. And again, if you put that on there, it doesn't even register with the disc. So third fan, I'll just try that, but just push that there. 9, 10. So they're all doing about 2/3 of what's expected of the minimum standard. Remember, building regs is a minimum standard, so they're not even meeting minimum standard once installed. In addition to the building regs as well, there's a new document recently introduced. It's called the Domestic Ventilation Compliance Guide, and it stipulates that if a fan's not complying to building regulations once installed, then the building control will not sign it off. So the 3 fans you've just seen there are a fairly good example of why the UK is suffering from condensation and mould in such a big way, because as soon as they get installed, they're not complying with the building regs. Just one other thing worth pointing out as well, one fairly important point. I'll just put that back on there. There's a lot of fans appearing on the market with flat front covers. So if I just put that flat front cover on this fan, you can see that the fan works perfectly, and then as soon as you put a flat front cover on it, it kills the fan. And basically all the flat front cover is really, it's like a wind baffle. But there's a lot of fans appearing on the market with flat front covers just because they look nice. So they're being marketed as neat and discreet, and they blend in nice with your tiles and your decorations. But you might have a nice neat fan, but it's not very nice when you get black mould. So be very careful. You fit a flat front cover on an axial fan, you're asking for trouble, unless you really fork out and spend some money and buy a decent one. You buy a cheap fan with a flat front cover, you're not going to meet building regs. I'll just demonstrate this fan here. If I put 3 metres of duct on there, because also, what's also worth mentioning is we get called out to a lot of condensation and mould problems in homes across the UK, and there's so many of them that have got fans, axial fans fitted on ceilings. Axial fans fitted on ceilings with 3 metres of duct. So there you go, I've just put 3 metres of duct on this fan, plus a 90-degree bend, plus a fixed grill, and you can see that it's doing 15 litres per second. So even on a fairly complicated duct run, this axial fan is still meeting building regs. And I'll just take that off, and let's just put one of these fans on, because you see so many of these installed on ceilings, so it's just worth demonstrating the actual rate of ventilation that the majority of these properties are getting. So again, 3 metres of duct, a 90-degree bend. You're not even getting half the building regs. 7 litres per second. 8, it's just gone up to 8. And an intermittent fan, which is terrible really. You know, a property with a couple of adults and kids creating a lot of moisture, you're asking for condensation and mould there. So that was System 1 fans, intermittent fans. Now we're going to talk about System 3. System 3 of the building regulations was introduced a few years ago into the Part F for new build. So System 3 is what's called DMEV, or decentralised MEV. And you've got to provide a prescribed amount of background continuous background ventilation rate to meet the building regulations, and there are certain conditions that apply, such as the size of the property, the number of occupants, and also you've got to have a prescribed amount of background ventilation rate. So it's only really suitable for new build. You see quite a lot of these kinds of fans cropping up in like social housing refurbs, and they end up with condensation and mould because you put in a fan in that's got a very small background ventilation rate, or 1 or 2 fans, and it just can't cope with the occupancy levels and the housing conditions in social housing and other existing private housing. This DMEV is working away at the moment. I'll just put it on the test rig. We'll see what happens to the disc. So there you'll see it's lifting the disc up, absolutely no problem. So even though it's running fairly low, at a fairly low level, it overcomes the resistance of the duct, no problem. If I just put that on the anemometer, you'll see that in free air that's doing 8 litres per second, 9 litres per second. And if I just put it on the middle duct there, so I'll replicate a typical installation with a wall sleeve and a grill, you're doing 7, should go up to 8 that. 8 litres per second, so it's meeting building regs, absolutely no problem in an installation. But what about on ductwork? I'll take that off there. Let's put some ducting on and see what it does to the fan performance. But I'm not going to put 3 metres on this, I'm going to put 15 on. So have a look at this. Connect that to the rig, and here comes 15 metres of duct. You can see the disc there just trying to lift up as I'm moving the duct around. So if I put that on my fan, let's see if it can overcome 15 metres of duct. Look at all that resistance. There you go. Absolutely no problem whatsoever. What if I put 30 on? Put 30 metres on. I wonder if that'll lift the disc. Remember, a lot of these fans, these System 1 fans, they couldn't lift the disc with no ducting on. And look at that. Absolutely no problem at all. No problem. I'll tell you what I'll do. I'll just put it on the anemometer. We'll see if it's still meeting building regs with 30 metres of ductwork. I'll just take that off there, put it on there. So we've got a typical installation now with a wall sleeve and a grill, but also with the addition of 30 metres of duct. There you go, 7, 8. It's doing 8 litres per second, so it's still exceeding building regs on 30 metres of duct. And that's because it uses this constant volume technology, but using a centrifugal motor instead of one of these weak axial fans that often struggle once installed. Let's see if I can kill this fan off. I'll put 15 more metres on. So 45 metres. Let's have a look at this. Here we go. There you go. It's blasting the air down the duct. No, absolutely no problem. I'll just put that back down there. Right, let's finish it off. 60. I've run out of ducting now, so here we go. Right, 60 metres of duct work plus a 90-degree bend and the disc to push up. Look at that. A fantastic performance. If I just put that onto there, I'll put my board on and reconnect it, and let's see if it still meets building regs, even with 60 metres of duct work. So remember, we were looking for 6 litres per second background ventilation rate, and there you go, it's doing 6, should do 7. It'll probably go up to 8 or 9, to be honest with you, because that's what it's been designed to do. If I wait long enough, there you go, it's gone up to 8. So that's a System 3 fan, and it just goes to show that there are fans available for contractors and developers that are guaranteed to meet the building regs. System 1 and System 3, and hopefully it's given some explanation of why some fans can meet the building regs once installed and some fans can't. Okay, thanks for listening.